Have you ever wondered how image-based AI is trained? Well, you're not alone. Artificial intelligence, or AI, is the simulation of human intelligence processes by machines, particularly computer systems. These processes include learning, reasoning, and self-correction. Now, image-based AI is a specialized form of AI that focuses on interpreting and understanding visuals. It's like teaching a machine to see, to recognize patterns and objects, much like how a human would. In today's world, image-based AI has become a vital tool. It's used in everything from autonomous vehicles that need to see the road, to medical imaging where it helps diagnose diseases, to facial recognition systems that unlock your smartphone. It's an exciting field with a lot of potential for growth and innovation. But how does image-based AI learn to recognize and interpret images? Let's dive deeper. The first step in training an image-based AI is data collection. Now, you might ask, why is data so important? Well, think of data as the raw material that fuels the engine of AI. It's like the ingredients in a recipe. If you want to bake a mouth-watering cake, you need the right ingredients in the right quantities. And the same holds true for training successful AI models. To train an image-based AI, we need a large, diverse dataset. This means we need thousands or even millions of images, and these images need to be varied. We can't just feed our AI a diet of cat pictures and expect it to recognize dogs. Our dataset needs to reflect the complexity of the real world. Now, there are two types of data we can use: labeled and unlabeled. Labeled data is like a picture book where every image is tagged with its name. This is great for supervised learning, where the AI learns by example. Unlabeled data, on the other hand, is like a mystery novel. The AI has to figure out the patterns and structures within the data itself. This is used in unsupervised learning, where the AI learns to understand data without any guidance. But what if our data is not diverse enough? Or what if we don't have enough data? That's where data augmentation comes in. Data augmentation is like a magic wand that allows us to create new data from our existing data set. We can flip, rotate, zoom, crop, or change the color of our images to create a whole new set of data. This not only increases the size of our data set, but also makes it more diverse. So, to sum it up, data collection is all about gathering a large, diverse set of images, using both labeled and unlabeled data, and augmenting it to suit our needs. And remember, the quality and diversity of our data can make or break our AI model. Once we have the right data, it's time to prepare it for the actual training. Before we can feed our data into the AI, we have to pre-process it. Now you might be wondering, what's pre-processing? Well, it's a little like cooking. You wouldn't just throw raw ingredients into a pot, would you? Similarly, we can't just feed raw data into our AI. First, we need to clean our data. This involves removing any inconsistencies, inaccuracies, or irrelevant information. Think of it as peeling and washing your veggies before you cook them. Clean data is crucial for the AI to make accurate predictions. Next, we normalize the data. This step is a bit like chopping your ingredients into equal sizes so they cook evenly. When we normalize data, we're scaling numerical data to a standard range. This helps ensure that no particular feature dominates others and allows the AI to process data more efficiently. Finally, we augment our data. In cooking, this could be like adding spices to enhance the flavors. In data pre-processing, augmentation means creating new data based on modifications of our existing data. We might flip, rotate, or zoom in on images, for example. This step helps our AI learn to recognize patterns in different contexts, improving its overall performance. So, there you have it. Cleaning, normalization, and augmentation. The three essential steps of data pre-processing. It's a little like cooking, right? And just like in cooking, it's all about the preparation. With our data ready, it's time to start training. The heart of the process is model training. After we've collected and pre-processed our data, we're ready to dive into the main event, training our model. This is where our artificial intelligence starts to learn and adapt. becoming more than just a collection of code and algorithms. To understand model training, think of it like teaching a child how to recognize different animals. You show them pictures of various creatures, explain what each one is, and over time, they learn to distinguish a dog from a cat, a bird from a fish. That's the essence of model training, albeit on a much more complex scale. We begin by feeding our model the pre-processed data. These are the images that it will learn from, the examples it will use to understand the world. This is where algorithms come into play. Algorithms are the lessons, the instructions that guide the AI in interpreting the images. Different algorithms can be used depending on the specific task at hand. Now let's talk about weights and biases. In the context of AI, weights and biases are not about physical heaviness or personal prejudice. Instead, they're parameters that the model adjusts during training to improve its predictions. A weight determines the importance of a particular feature in the model, while a bias helps to make the outputs more accurate. Imagine you're trying to predict the weather. The temperature might have a higher weight because it's a crucial factor, while the number of birds in the sky might have a lower weight because it's less significant. The bias, on the other hand, could be a constant value added to account for any systematic errors. Then we have the loss function. This is a way for the model to measure how far off its predictions are from the actual results. The goal of the model is to minimize this loss function. It's like a game of golf. The fewer strokes or errors you make, the better you're playing. The model uses an optimization process to tweak the weights and biases, aiming to reduce the loss function. It's a bit like a navigation system recalculating the fastest route based on current traffic conditions. The model adjusts and adapts, learning from its mistakes until it can make accurate predictions. And there you have it. The model is trained, it has learned from the data, and it's ready to interpret new images. But don't start celebrating just yet. The model is now trained, but our work isn't done yet. To ensure our model is ready for real-world application, we need to validate and test it. Now, you might be wondering, what's the difference between validation and testing? Well, let's break it down. Model validation is the process where we use a separate set of data, often called the validation set, to fine-tune our model. This set is different from the training data we used earlier. It's like a mock exam before the real test. It gives us an opportunity to adjust our model, tweak the parameters, and essentially optimize it to perform better. But why do we need this validation set? Can't we just use the training data? Well, that's a great question. The reason we use a validation set is to avoid overfitting. Overfitting is when our model becomes too good at recognizing the training data and starts to perform poorly on new data. It's like studying for an exam by memorizing all the answers without understanding the concepts. You'll ace the practice tests, but when the real exam comes with slightly different questions, you'll struggle. Now, let's talk about testing. Testing is the final step in assessing our model's performance. Unlike validation, which allows us to fine-tune our model, testing is a one-time shot to see how well our model performs on completely new data. This is the real deal, the moment of truth. We use a test set, a separate batch of data that our model has never seen before. This step gives us a clear picture of how reliable our model is. It tells us how well it can generalize, how well it can handle new data, and if it's ready for deployment. It's crucial because it ensures that our model can perform consistently and accurately, even when faced with new, unseen scenarios. At the end of the day, both validation and testing are essential parts of developing a robust, reliable model. They ensure that our model does not just memorize but learns and improves. Once our model passes these tests, it's ready to be deployed. And that's when the real magic begins. So, that's how image-based AI is trained. It's a journey that starts with collecting a diverse set of images, an integral step to ensure our AI can understand a wide range of visual data. Then, we dive into data preprocessing, where we clean, label, and augment the images, shaping them into a format our AI can learn from. Next, we proceed to the heart of the process, model training. Here, Our AI learns to identify patterns and make predictions, sharpening its skills over time. But the job isn't done yet. We move on to model validation and testing, where we rigorously evaluate the model's performance to ensure its accuracy and reliability. Each step is critical, and each step builds on the last. Together, they form a complex, intricate process that gives birth to the image-based AI you interact with every day. Next time you use an app or service that relies on image-based AI, remember the complex process behind it. Thank you for watching.